Welcome back, students. In the previous session, we were dealing with the numerical problems of Newton's second law. In this session too, we will be covering certain other numerical problems based on Newton's second law itself. So, let us begin with. For the questions, you may refer your NCERT science textbook. Now, please refer page number 121, example 9.5. Page 121, example 9.5. Question is, the velocity time graph of a ball of mass 20 gram moving along a straight line on a long table is given in the graph. How much force does the table exert on the ball to bring it to rest? So, this is the question. Now, let us write the given quantities first. The velocity time graph of a ball of mass 20 gram. So, mass of the ball is given as 20 gram. And we know that when we do any numerical problems, the units given should be in SI unit, or else we need to convert it. Here mass is given in the unit grams, and we know that the SI unit of mass is kilogram. So, we need to convert gram into kilogram. For that, 20 divided by 1000, the unit will change into kilogram. So, to change gram into kilogram, just divide it with 1000. So, the mass becomes 0.02 kilogram. When you divide 20 with 1000, it becomes 0.02 kilogram. Now, look the graph. The graph is a velocity time graph. The velocity is given in the unit centimeter per second and time is given in the unit seconds. So, graph depicts a velocity time graph in the units centimeter per second and seconds. And the ball was initially moving with a velocity 20 centimeter per second. This is the initial velocity. The ball was initially moving with a velocity 20 centimeter per second, and after 10 seconds, the ball came to rest. The ball came to rest and its velocity became 0. So, from the graph, initial velocity u is given as 20 centimeter per second. Again, we know that the SI unit of velocity is meter per second. So, let us convert the unit centimeter per second into meter per second. For that, divide by 100. And the unit change from centimeter per second to meter per second. 20 by 100 is 0.2 meter per second. So, we converted the unit centimeter per second to meter per second by dividing it with 100, and the answer is 0.2 meter per second. The final velocity v is 0 meter per second because the object came to rest. The question is clearly told that the object is coming to rest. So, final velocity v is 0 meter per second. And time, the total time taken for the whole process is 10 seconds. The total time taken was 10 seconds. So, these are the quantities given in the question. Now, the question is to find force, and we know that according to Newton's second law, F is equal to ma. Now, in the question, mass is given but acceleration is not given. Instead of acceleration, u, v and t is given. Initial velocity, final velocity and time is given. So, let us rewrite the equation F is equal to ma as F is equal to m into, we know acceleration is v minus u by t. So we just substituted the formula for acceleration, which is equal to v minus u by t. Now let us substitute the values. Mass is 0.02 kilogram into v is final velocity was 0 minus initial velocity is 0.2 meter per second. So u is 0.2 meter per second. For that, time taken is 10 seconds. So we just substituted all the values, that is 0.02 into 0 minus 0.2, it is minus 0.2 by 10, which is equal to 0.02 into minus 0.2 divided by 10 is minus 0.02. So 0.02 into minus 0.02 is minus 0.0004 unit of force is Newton. So the answer is negative 0.0004 Newton. Hope this problem is clear for everyone. Now let us move on to the next problem, that is page number 120, example 1. Example 1. And the question is, a constant force acts on an object of mass 5 kilogram for a duration of 2 seconds. It increases the object's velocity from 3 meter per second to 7 meter per second. Find the magnitude of the applied force. Now, if the force was applied for a duration of 5 seconds, what would be the final velocity of the object? So, this is the question. Now, let us read and write the given quantities first. A constant force acts on an object of mass 5 kilogram. So, mass of the object is given as 5 kilogram for a duration of 2 seconds. So, time duration is given as 2 seconds. It increases the object's velocity from 3 meter per second to 7 meter per second. So, initially the object was travelling with 3 meter per second. After the application of force, the velocity increased to 7 meter per second. So, initial velocity u is given as 3 meter per second and final velocity v is given as 7 meter per second. Find the magnitude of the applied force. You need to find force. This is the first part of the question. Now, second part is, if the same force was applied for a duration of 5 seconds, the same force was applied on the same object for 5 seconds. So, if time is 5 seconds, what will be its final velocity? What will be its final velocity? This is the second part to be covered. So, this is the question given. Now, let us solve the first part of the question, that is to find the force. We know according to Newton's second law, F is equal to ma. Again, here too, instead of a, the quantities v, u and t is given. So, let us write the equation as F is equal to m into v minus u by t. So, instead of a, we substituted its equation, a is equal to v minus u by t. Now, let us substitute the values. M is 5 kilogram into v is 7 meter per second minus u is 3 meter per second divided by time is given as 2 seconds. Reminding you, we are doing the first part of the question. The first part of the question, time is given as 2 seconds. So, we substituted that. Now, solving it, we get 5 into 7 minus 3 is 4 by 2. Simplify it. On simplification, we get it as 5 into 2, that is F is equal to 10 Newton. F is equal to 10 Newton. So we got the answer for F as 10 Newton. Now the same force F is equal to 10 Newton is applied on the same object of, that is, mass is 5 kilogram itself. The force 10 Newton is applied on the same object of mass 5 kilogram and initial velocity 3 meter per second for a duration of 5 seconds. Time is changed from 2 seconds to 5 seconds. Now here we need to find the final velocity. This is the second part of the question. Force equal to 10 Newton is applied on the same object of mass 5 kilogram which was moving with a velocity 3 meter per second for a duration of 5 seconds. Question is to find the final velocity. Again, let us write the equation. Equation for Newton's second law is F is equal to ma. Again, rewriting the equation as m into, instead of a, v minus u by t. V minus u by t. Here in this question we need to find final velocity v. So let us make some rearrangement in this equation. Just take this t to the other side. So already we have an f here. When we take t to the other side, it becomes into t. Here it was divided by t. When it goes to the other side of the equation, it becomes into t. Now move this m to the other side. Here it was m into. So when we move it to the left hand side, it becomes divided by m. So ft by m is equal to v minus u. Now let us get an equation for v. So v is ft by m. Move this minus u to the other side, it becomes plus u. So this is the equation to find final velocity. So v is equal to ft by m plus u. So we got the equation to find final velocity as ft by m plus u. Now substitute the values. F is 10 Newton, time is for 5 seconds, mass is given as 5 kilogram plus u is, initial velocity was 3 meter per second. So plus 3. 5 and 5 got cancels off. Remaining is 10 plus 3, which is equal to 13 meter per second. We are finding velocity. So the unit is meter per second. Answer is 13 meter per second. Hope the question is clear. Now let us pass on to the next question. Again, refer page number 121, example 8.4. Page 121, example 9.4. Sorry, it is example 9.4. Question is, a force of 5 Newton gives a mass m1 an acceleration of 10 meter per second square and a mass m2 an acceleration of 20 meter per second square. What acceleration would it give if both the masses were tied together? Okay, listen carefully. It's a little bit confusing. So listen carefully. A force of 5 Newton. So force F is 5 Newton gives a mass m1. So first mass is m1. For the mass of the first object is m1, and this force gives an acceleration of 10 meter per second square on the first object. So acceleration on the first object is 10 meter per second square. Again the same force acts on another object of mass m2, and again that second object is accelerated by 20 meter per second square. So, acceleration of the second object is 20 meter per second square. 20 meter per second square. Question is, what acceleration would it give if both the masses were tied together? So, if both the masses were tied together, then total mass will be m1 plus m2. If we tie both the masses together, then the total mass of that object will be m1 plus m2. The question is to find the acceleration when both the masses are tied together. When both the masses are tied together, the total mass becomes m1 plus m2. Then what will be its acceleration? What will be its acceleration? This is the question that we need to find. So, again, these are the quantities given and this is the question that we need to find. Again, let us use Newton's second law itself over here. We know that F is equal to ma. So, in this question we need to find acceleration. So, from this second law, let us get an equation for A. From F is equal to ma, equation for A is F by m. So, in this problem we will be using this equation to solve. A is equal to F by m. We will be using this equation to solve the problem. A is equal to F by m. So, here we need to find the total acceleration when both the masses are tied together. So, we need to find acceleration when both the masses are tied together, means total mass is m1 plus m2. Here total mass is m in this equation. So, in this problem we need to find acceleration when both the masses are tied together. When both the masses are tied together, its total mass becomes m1 plus m2. So, that is equal to F by, here m is the total mass, that is m1 plus m2. So, this is the equation that we will be using. So, in order to solve this we need m1 plus m2, but we doesn't know the value of m1 and m2. So, before solving for acceleration, we need to get the values of m1 and m2 first. We need to solve for m1 and m2 values first. So, now let us see what is m1. We need to find m2, then we need to solve for m1 plus m2, then we need to solve for the acceleration when both the masses are tied together. So, this is what we need to solve. So, in order to solve this, we need to solve all these initially. Okay. Now, so let us find the mass m1 first. So, again we have the equation F is equal to ma. A constant force is applied on both the objects. The force applied on both the objects are the same. So, let us consider for the first object, the equation becomes F is equal to m1a1. m1a1, and we are going to find m1 here. So, m1 is F by a1. F by a1, and in the question F is given as 5 Newton. F is given as 5 Newton. So, 5 by, again a1, acceleration of the first object is 10 meter per second square. So, a1 is 10. So, mass of the first object is 1 by 2 kilogram, which is equal to 0.5 kilogram. So, we solved for m1. Now, similarly solve for m2. Again we have F is equal to ma. So, the equation for second object is F is equal to m2 A2. Here we need to solve for M2. So the equation becomes M2 is F by A2. Again, in the question is clearly told a constant force is applied on the same object. That means the forces applied on both the objects are the same, which is equal to 5 Newton, and it created an acceleration of 20 meter per second square on the second object. So F is 5 Newton, acceleration created is 20 meter per second square. When you solve this, you will get the answer of M2 as 1 by 4. When you cancel it, you will get as 1 by 4 or 0.25 kilogram. 0.25 kilogram. So you solve both for M1 and M2. Now let us find the total mass. Total mass when both the objects are tied together is total mass is M1 plus M2, which is equal to M1 is 0.5 kilogram and M2 is 0.25 kilogram. So 0.5 plus 0.25, which is equal to 0.75 kilogram. So this is a total mass, that is 0.75 kilogram. The question is to find the acceleration when both the masses are tied together. This is the question. Again, Newton's second law is F is equal to ma. So A is equal to F by m. And our question is to find the acceleration when both the masses are tied together. When both are tied together. So equation is F by m is the total mass, that is m1 plus m2. On substituting, the total acceleration is F is again 5 Newton. Total mass is 0.75. So total mass is 0.75. On solving this, you will get the answer as 6.666, that is 6.67 meter per second square. On solving 5 by 0.75, you will get the answer as 6.67 meter per second square. So this is the acceleration when both the masses objects are tied together. Little bit confusing but easier. So that was the third question. Now let us pass on to the exercise questions. Now let us pass on to the exercise questions which is there on page number 128. Page number 128. Refer page number 128. Question number 6. Page number 128, question number 6. A stone of 1 kilogram is thrown with a velocity of 20 meter per second across the frozen surface of a lake and comes to rest after travelling a distance of 50 meter. What is the force of friction between the stone and the ice? That is a question. So let us write the given quantities first. A stone of 1 kilogram. So mass is given as 1 kilogram is thrown with a velocity of 20 meter per second. Stone was thrown with a velocity 20 meter per second across the frozen surface of a lake and comes to rest. The stone comes to rest means final velocity is 0 because the stone is coming to rest. So initially the stone was travelling with a velocity 20 and finally it came to rest means final velocity is 0. after traveling a distance of 50 meter. So, it travelled a distance of 50 meter and then it came to rest. What is the force of friction between the stone and the ice? So, you need to find the frictional force. So, these are the quantities given, and we know that the equation to find force is F is equal to ma. So, instead of acceleration, the quantities like u and v is given. So, let us rewrite the equation as F is equal to m into, instead of a, substitute its equation, that is a is equal to v minus u by t, and we got the equation as F is equal to m into v minus u by t. Now, in the question, mass is given, well, final velocity v is given, initial velocity u is given, but time is not given. Instead of time, the distance travelled by the stone is given. Equation is m into v minus u by t. Equation became F is equal to m into v minus u by t. But again we doesn't have time. Time is not given in the question. Instead of that, distance covered by the stone is given. So, let us go back to the equations of motion which we have covered in the chapter motion. And we have an equation 2as is equal to v square minus u square. So, from this equation we can solve for a. We can solve for a. So, a is v square minus u square divided by, take this 2s to the other side. So, here on the left hand side 2s was multiplication, 2 into a into s. So, when 2s move to the other side, it becomes division. So, v square minus u square by 2s. Now, substitute the values for v, u and s. V is 0 minus u square is 20 square divided by s is 2 into s. S is 50 meter. So, A is 0 minus 20 square by 2 into 50. Now, 0 minus 20 square is minus 20 square by 2 into 50 is 100. Minus 20 square is minus 20 square is minus 400 by 100. So, answer is minus 4 meter per second square. So, you solve for acceleration and you got the acceleration as a is equal to minus 4 meter per second square. Now, you can easily find force using the equation F is equal to ma. So, that is m is given as 1 kilogram. M is given as 1 kilogram, acceleration is minus 4. So, 1 into minus 4 is minus 4 Newton. Minus 4 Newton is the answer. And you have a negative sign in the answer. It shows that frictional force is opposite to the direction of motion. Force is to show the frictional force is opposite to the direction of motion. We have a negative sign in the question. Now, we already know that frictional force is an opposing force. So, to show the opposing nature, we have a negative sign. The magnitude of the frictional force is 4 Newton. Hope it is clear. Now, let us move on to the 8th question of the exercise. 8th question, page number 128, question number 8. Question number 8. Question is, an automobile vehicle has a mass of 1500 kilogram. What must be the force between the vehicle and road if the vehicle is to be stopped with a negative acceleration of 1.7 meter per second square. So here an automobile has a mass of 1500 kilogram. So mass is given as 1500 kilogram. What must be the force between the vehicle and the road? So you need to find force. If the vehicle is to be stopped with a negative acceleration of, so vehicle need to be stopped with a negative acceleration of 1.7 meter per second square. Negative acceleration of 1.7 meter per second square. So acceleration is negative 1.7. We need to find force. Again, it's a direct question. According to Newton's second law, F is equal to ma. So m is 1500 and acceleration is negative 1.7. When you multiply it, you will get the answer as minus 2550 Newton. Again, we have a negative sign in the answer because initially the automobile was moving. And the question asked is, what must be the force between the vehicle and the road if the vehicle is to be stopped? So it is opposing the motion. This force applied is opposing the motion of the vehicle. So that is why we have a negative sign in the answer. Since the force applied between the road and the vehicle is opposing the motion of the vehicle, we have a negative sign in the answer, and we got the answer as F is equal to minus 2550 Newton using the equation F is equal to ma. Hope the problems that we discussed today is clear for everyone. Please do write and learn all the problems. Thank you.